Today we are going to learn about the differentiation of Trigo functions. We recall from differentiation that the differentiation of sine will give you cosine of the same function, and then the differential of the function must be placed in front. So to derive the integration rules, we will then integrate both sides with respect to x. So we notice that on the right hand side we have the integration of the cosine function with respect to x, and on the left the differentiation actually cancels with the integration, and the dx cancels with the dx. So that will yield the result that the integration of a cosine function fx will give you sine fx plus c. Now we will do the same steps to the differentiation of cosine. Now we recall that the differentiation of cosine fx is minus sine fx with the differential found in front. So again, to derive the integration rules, we'll integrate both sides with respect to x. So the integration of sine fx is found to be negative cosine fx, because on the left hand side the integration cancels the differentiation and the dx gets cancelled out. So we notice that this minus sign actually turns out to be on the left because we multiply both sides by a minus. Last but not least, we recall that the differentiation of tangent fx is secant square fx with the differential found in front. So again, we integrate both sides with respect to x. So we yield the result that the integration of a secant square fx is equals to tangent fx plus c. So in summary, the rules of integration will be like this. The integration of cosine will be sine fx. Integration of sine will be minus cos fx. And the integration of secant square will be tangent fx. Now realize that in integration, the differential of the function fx must always be found in front. And after integration, this differential f prime x actually disappears. So this becomes, the f prime x becomes the criteria for integration. We must ensure that f prime x can be found before we give the results for the integration of cosine into sine. And this applies for the rest of the cases. Now, let's take a look at one example. Let's start with the integration of single trigo terms. If you're asked to integrate cosine 3x dx, what we do is, we must determine the function fx, which is 3x here. We differentiate 3x, which will yield 3. Now, in the question, there isn't a 3 in front. So, we can create the number 3 and cancel out 3 with a 1/3 outside the integration sign. So, if you take 1/3 times 3, you get 1, which is equal to the original question. Now, in creating this 3, the differential of the function 3x is already found in front. So we can immediately write down the integration of cosine 3x to be sine 3x. And this 1/3, which is outside the integration sign, remains, but the differential 3 will disappear after integration. Since this is an indefinite integral, again, we have the plus c. Let's take a look at another example. What if we are asked to integrate 5 sine 2x dx? Again, we look at the function fx, which is 2x. We differentiate 2x, which will yield 2. But in the original question, there isn't a 2 found in front, but a 5. So what we do is, we take out the 5 outside the integration sign. Then we create the differential 2, cancel the 2 with a half outside. In this case, the condition for integration is satisfied, whereby f prime x is already found in front of fx. So now, integration of sine 2x will then yield minus cos 2x. And we copy the 5 over 2 in front of the integration sign, and then there is a plus c. Now let's take a look at the next example to reinforce this idea. Now, if we are asked to integrate secant square half x dx, again, we differentiate fx, which is half x, and we get half. So again, half is not found in front of the question, so we create our own half and cancel with the 2 outside. In this case, we know that integration of secant square yields tangent half x, and the differential half actually disappears. Then we can copy the 2 right in front, and then we plus c. Now with 3 examples, I hope the integration of single trigo terms have become clear. We will now proceed to the integration of 2 trigo terms separated by plus or minus. Take for example, we are asked to integrate sine x minus cos x with respect to x. We recall that differentiation is actually distributive over addition and subtraction. So similarly, integration, which is the reverse process of differentiation, is also distributive over addition and subtraction. So we now distribute the integration between sine x dx and then minus integration of cos x dx. So we know that integration of sine x is minus cos x, minus integration of cos x is sine x, plus c. And that's how we handle the integration of 2 or more terms separated by plus or minus. Next, we go on to the integration of the square of trigo terms. Suppose we are given a cos square x, and we are asked to integrate this term with respect to x. Now we know that the integration of cos square x dx cannot be carried out. So we try to replace cos square x by an integrable term. Let's recall our double angle formula. If we double this given angle x, we'll get cos 2x. Can we relate cos 2x with cos square x? Yes. We note that cos 2x is 2 cos square x minus 1. Adding 1 on both sides, we get 2 cos square x plus 2 cos square x is equals to cos 2x plus 1. Then we divide both sides by 2. So we get cos square x is equals to cos 2x plus 1 over 2. So in this case, we can see that though cos square x is non-integrable, we can replace it by an integrable term. So that's what we have done. We have done a substitution using double angle formula. And then now there's a half here, which is a constant. And I can take the constant out of the integration sign, giving me the integration of open bracket cos 2x plus 1 close bracket dx. Again, I distribute the integration among the two terms. So integrate cos 2x dx will yield half sine 2x plus integration of 1 dx will yield x. So whole thing is bracketed with half in front plus c. Expanding this bracket, half times half sine 2x, I get 1/4 sine 2x plus half times x, I get half x, and then plus c. That will be my final answer to this question. So we have done the integration of cos square. How about the integration of sine square terms? Suppose you are asked to integrate sine square 2x. We use the same idea. We double this angle, which gives us 4x, and we try to relate this term with cos 4x. Let's recall, cos 4x is equals to 1 minus 2 sine square 2x. So if I plus 2 sine square 2x on both sides, and then minus cos 4x on both sides, you will get 2 sine square 2x is equals to 1 minus cos 4x. Now we divide by 2 on both sides. So we'll get sine square 2x as 1 minus cos 4x divided by 2. So we come back to the question and we replace sine square by cos 4x. Again, we realize that there's a constant term half, and we carried it out of the integration sign. So we are left with the integration of half, integrate, open bracket, 1 minus cos 4x, close bracket, with respect to x. Now I integrate 1, subtract, integrate cos 4x separately. So integration of 1 yields x, minus integration of cos 4x yields 1/4 sine 4x. Whole thing bracketed, multiplied by half in front, plus c. Again, expanding this bracket, I'll get half x minus 1/8 sine 4x plus c as the final answer. Last, how about the integration of tangent square terms? Do we still apply double angle formula? Of course not, because if you were to replace tangent square x by tangent 2x, you'll find that the net result is non-integrable as well. So what should we do? Now, if you can recall, our cheer 1 plus Mr. Tan in secondary school. Since 1 plus Mr. Tan in secondary school, okay, we know that 1 plus tangent square x is equals to secant square x. Subtracting 1 on both sides, we get this formula. You can see that though tangent square x is non-integrable, but secant square x is integrable. So that's what we'll do. We'll substitute tangent square x by secant square x minus 1. Now, we distribute the integration over the negative sign. So we integrate secant square x dx, we'll get tangent x. Subtracting integration of 1, we'll get x plus c. So congratulations, we have now completed the examples on the integration of the square of trigo terms. Now, let's go on to see a more challenging question. Now, let's do the challenger question. What if we are asked to integrate sine x times cos square x dx? How we are going to approach this term where a square term is multiplied with another trigo term? Now in this case, we recall the power rule for integration. Now we recall that the integration of fx raised to power n dx is just fx raised to the power of n plus 1 over n plus 1 plus c. Again, a necessary criteria is the differential of fx must be found in front. So f prime x must be found in front of the bracket. And f prime x will disappear once you cheer your power rule. Power plus 1, power comes down. So what do I do to this question? I first put a bracket over over cos x raised to power 2, and I differentiate cos x, which is minus sine x. Now there isn't a minus here in the question, so I generate my own minus and cancel with the minus outside the integration sign. So now f prime x is there. So I will just have to do my power rule here. Power plus 1, which is 3, power comes down, copying the function fx. And this minus outside the integration sign is copied over. F prime x in the process has disappeared, plus c. And with this power rule of integration, we managed to complete this challenger question. Congratulations, we have completed the whole lesson on the integration of trigo functions.